Right, glycolysis takes place outside the mitochondria in the cytoplasm. The purpose of glycolysis is to break down 6-carbon glucose into 2 pyruvate molecules, which is 3-carbon. This metabolic pathway requires no oxygen and can be divided into 2 energy steps: the energy investment and energy harvesting step. In the energy investment step, 2 ATP are used to activate the glucose by adding phosphate. Glucose then splits into 2 G3P, and a total of 2 ATP is used to jumpstart this process. It then moves into the energy harvesting process, where G3P is oxidized, which is the removal of electrons. Phosphate groups are then used to synthesize 2 ATP. This is called substrate synthesized ATP, and oxidation once again occurs after that, removing water or H2O. Substrate ATP once again occurs and 2 more pyruvate result. This is a total production of 4 ATP, and you used 2 earlier, so this is only a net gain of 2. Alcohol and lactate fermentation. This is an anaerobic process that produces a limited amount of ATP, this is in the absence of oxygen. Depending on which enzyme is present, bacteria can either produce organic acid, the lactate, or alcohol. It regenerates NAD+ for either process to use once again. It produces less when oxygen is present, but enough for the cell to operate. Lactate is for a rapid burst of energy for animals, and in the alcohol, it produces alcohol, which humans obviously love, and it's used in products like for bread raising, like yeast. It only has a 2.1% efficiency rate, so it only gains plus 2 ATP, unlike the 39% efficiency rate for glycolysis.